Thank you. All right. So we're going to start with section unit 3, section 1, and this is quite a bit interesting. You remember, right from the onset, I told you that for nature of science, we don't have a specific curriculum. All that we do is we borrow from around. We can do a bit of borrowing from philosophy, can do a bit of borrowing from sociology, psychology, and all this. All those that are important to this particular course. And so today we're going to do a bit of philosophy. We're going to talk about a bit about how science started and some philosophers that have played critical role to the development of science. Some of the views may be contradicting though, but they all came together to give us what we have now as science. And in the course of that, we're going to discuss a lot of them, their views, and then we'll look at what we can take from there. So we're going to start with section 1. We talk about early philosophies of science. Now, science itself, when you look at science actually, its nature is not predictable. It's not a magic show that you can easily predict the outcome. And so because of that, it gives science and scientists and philosophers a bit to think about. Now, one thing I want you to understand is the fact that science wasn't developed by scientists. It was developed by philosophers. Yes. Science, at that time, they were philosophers. They weren't scientists. And so these philosophers started the development of science. All right. These philosophers brought out their thoughts to construct what we see as science. And as it went on, there were some that were discarded, there were some that were accepted. So the nature of science itself, the nature of things around us, whatever is going on, gave people the chance to think about a lot of things. They were wondering why things were happening. They were wondering why certain things have to be how they were. It gave people a lot of things to think about. And their thoughts and views actually helped shape the science that we all know today. And so we are going to start with one person. Start from the top. Talk about these people. The first person I'm going to talk about is empirical. The first person we're going to talk about is empirical. Now, this was one of the greatest philosophers as at that time. At that time, Greeks were thinkers. And so philosophers were known as thinkers. They were known as thinkers. And so if you could think and you could analyze certain things, you become a philosopher. And so Empirical was one of the earliest philosophers in Greek and was one of the most powerful people. Now, he is attributed with coming out with a theory of the material things of nature. What actually makes up matter? What actually makes up matter? Now, he proposed the 4-element theory. So he sat down and asked himself, there's matter, things exist. What actually makes up these things? What actually makes up these things? When you pick a matter, what are some of the things that comes together to form that matter? And bear in mind that at that time, the theory of matter having atoms, molecules, and those things weren't propounded yet. So he was trying to find out, what actually makes up matter? And from his philosophy, or from his thoughts, he came up with a 4-element theory. He said that every matter is made up of 4 elements. That was what he thought. But that was his philosophy. That every matter is made up of 4 elements. These 4 elements comes together to form every matter, and so every matter will have these 4 elements. According to him, the 4 elements were earth, air, fire, and water. So according to empirical, the material cause of things were 4: earth, air, fire, and water. You can have your own view, but that is what he taught. And that was his philosophy. And so he suggested that everything came from the root. Everything came from what he called a root. Every matter has what we call or comes from a root. Just as we will say all living things came from God or a supernatural being. He believed that everything came from a root. He later named the root elements. And according to empirical, these elements were earth, fire, water, and air. So everything on earth came from these 4 elements. If you are not part of these 4 elements, or if you don't come from these 4 elements, then you are not matter. Later on, a lot of philosophers also hopped onto his theory. As I said earlier philosophers were mostly concerned with thoughts. And so once you said something that actually made sense, they all hop on it. They weren't basing their philosophies on observations, no, experimentations, and no. They were basing their philosophies on thinking. They look at the things and they think. And if it makes sense, they will accept it. And so earlier on, other philosophers like Aristotle also hopped on empirical theory. Aristotle also proposed a 5th element called ether. Aristotle also proposed that in addition to empirical's 4-element theory, earth, water, fire, and air, he also added another one called ether. Now, Aristotle added another one because he wanted to also cater for the other elements or substances in space. So that was what Aristotle was also thinking about. He believed that above the air, there were also things that existed in space. There were also other heavenly bodies. And so in order for Aristotle to also cater for that, he added a 5th element called ether. So that ether would also talk about those things that exist in space or the heavenly body. Now, another Chinese philosopher, Taoist or Taoist, also added a 6th element, which was also wood. And so now we have 4 from empirical: earth, water, fire, and air. Aristotle added his own 5th one, that is ether, which is to cater for heavenly bodies. Now, another person, a Chinese philosopher, also added his own 5th, which was wood. I don't know what he was thinking, but he also added wood as his 5th element to empirical's 4 elements. Now, a Japanese philosopher also thought of things not of our everyday life, things that we don't encounter in our everyday life. You know, we encounter a lot of matter in our everyday life, but what are the things that we don't encounter in our everyday life? And obviously, all those philosophers were talking about things that we encounter in everyday life. And so he wanted to shift a bit and look at things that we don't encounter in our everyday life. So he also suggested a 5th element called void. Now, according to him, void is not the absence of anything. According to the Japanese philosopher, when we say void, it doesn't mean something doesn't exist. It means that it exists, but we don't encounter it in our everyday life. And so to also cater for those things that we don't encounter in our everyday life, the Japanese philosopher also proposed a 5th element called void. And so aside empirical's 4 elements, we had Aristotle proposing ether to cater for the heavenly bodies. The Japanese philosopher also proposed a 5th element called wood. We have the Japanese philosopher also proposing void to also cater for things that we don't encounter. Now, there was this philosopher also from New Zealand called Morris. He also proposed another 5th element called flora, he also proposed another fifth element called flora. So you see, they were all hopping on the idea, or they also accepted the idea of Empedocles, just that they also had their own thoughts. So Aristotle, thinking about the heavenly bodies, also added his own elements to just to cater for those heavenly bodies. And so the limitations of Empedocles' four-element theory was those that these philosophers thought were absent, so they added. And so the New Zealand philosopher Morris also added flora as his own element because he felt flora also has to be an element and existed. Okay, but the basic foundation is that this four-element theory from Empedocles actually sets the tone for the beginning of scientific discourse. This four-element theory proposed by Empedocles actually set the tone for scientific discourse. It started prompting people to think more and also to start, finding more, because it was more like a competition. Once someone says something, another group of people would want to dispute what the person has said or the person's philosophy. So they will start working. They would also start working and then start making sure that they also get something that is laudable and reasonable enough for others to explain or to accept. And so that is basically what sets the tone for the development of scientific knowledge. Empedocles for element theory and the other additions from other philosophers, Aristotle, Taoist, Morris, and all those people also added their own fifth element to it just to make it make sense. And so the beginning of science, or the beginning of scientific knowledge, actually started with this. Any questions so far? Any thoughts about this philosophy from Empedocles? I hope you can hear me. Okay. All right, Nana Bimpong.
Yes, sir. Thank you. So, apart from Empedocles' proposal, those that brought their fifth elements, were they accepted or they were rejected?
Okay, so as at that time, as I said earlier, there was just basically philosophy's thoughts. Okay, so they accepted Empedocles' philosophy, and then these people also added theirs. So as at that time, the theory reigned for a particular period of time before other people also started disputing them. Okay, so it reigned for a particular period of time, and during that time, these people were the top scientists, philosophers at that time. They were well respected and well honored, and so whatever they put up there is accepted, unless you have something more advanced and more evidential to dispute that. So their Empedocles theory was accepted for a period of time. All these people just made additions to it, but the theory the theory actually stood for a period of time. What all these people did were just to make additions to it. So the additions further, gave weight to the theory, but it just lasted for a period of time.
Oh, okay. Thank you.
Yes, sir.
All right. Yes, sir. Yes, madam.
Please. So, if I understand you, meaning that all these people that have made additions to the first person, Aristotle, right?
Mhm.
Aristotle talking about air, water, earth, the four elements. Good.
Mhm.
And others also add their own.
Yes.
It means no philosopher or even in our modern day, no scientists have yet come out to also argue or prove something beyond what they have said.
So see, so as we go along, there are more philosophers that we'll talk about. You realize that as it went on, as we go on, you realize that there were other people who also came with philosophies to actually dispute what Empedocles also brought.
Okay.
You understand? what empirical did was, though his theory is not founded on evidence and wasn't accepted for a long period of time, it actually sets the tone for other people to also build upon. Like you are laying a foundation, you are building, you lay a foundation, and based on the foundation, you build. You get it. So his theory at that time stood for a period of time, but other people also came up and, based on the observations and evidence, came up with a bit, reasonable theories, which were later also accepted.
Okay. Thank you, sir.
Okay. So please, the course rep, what do you call it? The administrator of the WhatsApp group, Doc wants you to add him to the WhatsApp platform. I think his number is in the chat. So the administrator of the platform should add Doc to it. I hope you can see the number in the chat. Is anyone as an administrator here of the WhatsApp platform? Anyone as an administrator here?
Maybe today.
Hello. Come again.
Okay, maybe today the person is not present.
So no one has the administrative power in the WhatsApp group to add Doc.
Let me try and see.
All right. So yeah. But the number is there, so don't worry, we'll work on that after the class. All right. So please, any other question? So that was it. That was the earlier philosophers, and that was Empedocles' thought process, and that was what he taught. Okay. Now, as you saw, aside Empedocles, just to answer some of your questions, his four-element theory actually reigned for about 200 years. When he established that theory, it was widely accepted and it reigned for about 200 years. So it was actually disputed. And so you understand that for a long period of time, you would actually dispute this. And then we all know that matter is made up of atoms, molecules, and even in atoms, you have subatomic particles, proton, neutrons, and even in that one, we also have subatomic particles, the quarks, and all those stuff. Now we all know that. So in your mind, you dispute it, and in your mind, you'll be asking questions: why would people hold on to such a lie for a long period of time? But that was how life was. These philosophers were well respected and accepted. So whatever they bring out, it's accepted. Right. Okay. So that is it. Now we move on to section 2, where we look at another philosopher who also, or philosophy, which also stood the test of time, which also contributed to science. And we are going to look at Francis Bacon. We are going to look at another philosopher, very, very important philosopher, Francis Bacon. Now, he introduced what we call the logic deductions. He introduced what we call the logic deductions. I know you do critical thinking. If you've not done that, you do critical thinking, and you are going to be taking active and deductive reasoning. But deductive reasoning is actually ascribed to Francis Bacon. He is noted as the one who actually started deductive reasoning. Now, Francis Bacon was actually born in London in the year 1561. He studied law at a very young age, and science was just a hobby to him. Now, he proposed the idea of induction and logical deduction. He proposed the idea of induction and logical deduction. Now, when we say induction reasoning, what does it mean?
The person again.
when we say induction reasoning, what do we mean by induction reasoning? Induction reasoning. Yes, Mr. AJ Prince.
That is making an argument or presenting a statement based on a previous observation or recurring observation.
Recurring observation. Okay. All right. Okay. Thank you. And any other person with any view? Induction reasoning. Okay, so Francis Bacon's philosophy or idea about science is that the nature of science should be based on inductive and logical deductions. That is what he taught, or that was where he was coming from. That the nature of science should be based on inductive and logical deductions. Okay, so I'm asking you, when we say inductive reasoning, what does it? What do we mean by inductive reasoning? Now, according to, or when we say inductive reasoning, we're just talking about you making a general statement based on observations. So based on your observations, you make general statements. Okay. Now, let me use a practical example to this. Now, if how do I do it? How do I say? So we can make a statement that aluminum is a metal. Aluminum is hard. That is a statement, right? Aluminum is a metal. Aluminum is hard. Good. We can see iron, copper, zinc. These are all metals and they're hard. And so we can make a general statement that all metals are solid. Please, do you get an example? You see aluminum. Aluminum is hard. Okay, so and aluminum is metal. So aluminum is hard. That was based on observation. You see copper. Copper is a metal, and you saw that copper is also hard. So you pick copper as a metal. Now you see zinc. Zinc is a metal, and zinc is hard. So based on your three observations, you conclude that in general all metals are solid. So that is what we mean by inductive reasoning. You are making a general statement to affect everything based on just observations. Please, are we clear on that? Are we clear?
Please, if you can take it again, like the use of the metals you use to explain.
Okay. So what I said was that when we talk about inductive reasoning or induction, you are making a general statement based on series of observation. Okay, you are making a general statement based on series of observation. I'm coming, Madam Philomena. I'll attend to you now. Let me clarify. You're making series of observations. Sorry, a general statement based on series of observation. And I said that, for example, when you pick aluminum is a metal, and it's hard, it's solid. So you observe that aluminum is solid. You put it down. You pick zinc or copper. You show that these two are also solid, are also metals, and they are solid. And so based on these three observations, you make a general statement that all metals are solid. Okay, so making a general statement based on these observations is what we call inductive reasoning. Madam Linda, is that okay? Okay, Madam Philomena, let's hear you.
Sir, please, is the general observation made on the physical appearance of the material or the thing?
It's an observation. It can be physical, it can be whatever. You are just making an observation.
All right.
Okay.
Thank you. Okay.
And the the most important thing is not even about observation, but rather the generalization. So
Okay.
yes, so the
Okay. Well understood.
generalization, making a general statement, making a general statement that based on these few observations, everything it affects everything is what we call inductive reasoning. Okay, and so according to Beacon, induction, the word induction describes how a statement is extended from applying to a few known examples, but true to all. Okay, so according to Beacon, induction is when a statement, okay, is true for all rather than being applied to just a few. And so, Francis, yes, Mr. Eric. Mr. Eric.
Hello, sir. Sir.
Yes, sir.
Hello, sir.
Yes, sir. Please, you can talk.
Sir, sir, please, so it's just a matter of generalizing everything based on what you see
Exactly.
about a group of things.
Yes. So
Okay.
that is what that is what Francis Bacon, yes, brought in, okay, inductive reasoning and logical deduction. You make
Okay.
general statements based on
Okay, sir.
observation.
Thank you.
Or thank you too. Or a statement is true for all, rather than you making it about a few stuff. Okay, so there's another practical example where you say you pick salt. Salt is commonly known as sodium chloride, the common salt that we use. You look at it and you saw that it is crystalline in nature. Another salt, calcium chloride, you examine it and you see that it's also crystalline in nature. Okay, and so you look at all these things and then you make a general statement that since these three salts are crystalline in nature, means all salts are crystalline in nature, which is wrong. But the idea of you making a general statement based on your observation is what we call inductive reasoning. And that was what Francis Bacon proposed, that science should be based on inductive reasoning and logical deductions. That was what he's coming from. So Empirical proposed the four-element theory. Now Francis Bacon is also saying that science should be based on inductive reasoning, where we make general statements based on observations. And though that is what he taught. And from him, the statement that we make, the general statement that we make, is actually induced from observations. Okay. Okay. So all metals are solids because you've observed aluminium and all those things, and you've made your induction. You've made your inductions, inductive reasoning. You've reasoning that all metals are solid. That is it. Now, the logical deduction is your ability to generalize the statements that all metals or all metals are solid. That is the aspect of the logical deduction that you also added in addition to the inductive reasoning. Mr. Solomon.
Sir, please, my question is, um, based on Francis Bacon's, what he said that it is based on observation, that means what we see. So does this also refer to what the Japanese also said that, according to the fifth element, the void, because we can't see the void. So does this refute that theory or proposal?
Well, probably because as we said, now one thing I have to add is the fact that during Francis Bacon's time, the philosophy of the four elements, or the theory of the four elements, was beginning to wade off. Okay, it was beginning to people were beginning to, people were tired of it, and they were seeing reasoning, and they were actually disputing it. Okay, so it's in line with what you said. Bacon's philosophy was also emerging at a time where the theory of the four elements was actually being discarded. So you can say, based on your deductions, you can say that it's refuted. Is that okay?
Yes, sir. Thank you very much.
Thank you, too. Okay, so all metals are solid. That is your inductive reasoning. You make the general statement. Okay, so your ability to relate every metal, okay, to this particular reasoning is what we call induction. So if you pick a metal that you don't even know, and you see that it is solid, you can directly say that it's a metal. And your ability to deduce this from the general statement is what we term as logical deductions, because the statement is there, and that logical statement or that inductive statement serves as a premise, and so as a reference. So immediately you see any metal, you assume that it is solid. But meanwhile, now we know that mercury is liquid, and the other metals too that can behave as liquids at room temperature or at extreme temperatures. Okay, but at that period of time, that is what people accepted. Once the general statement is there, the statement serves as a reference. So immediately you pick a salt, you generally assume or you deduce based on the premise that, or based on the general statement that it is crystalline. And that was what they were living at. Okay, now, one other thing that Bacon actually also proposed was a scientific source of scientific knowledge. Aside building science on inductive reasoning and logical deduction, he also said that scientific knowledge should be constructed from experience. Scientific knowledge should be constructed in experience. And he also accepted the fact that through experience, observations can be made. And so observations should be carried out during experiments and also interaction with nature. So he was more of an empiricist. We gain scientific knowledge through our experiences. And so Francis Bacon was known to be an empiricist. People who believe that knowledge is obtained from experience. And so that was the point. That was where he was coming from. Now, so this was his philosophy, that you make general statements based on small observations, and then scientific knowledge is constructed based on our experience. Now, every theory has its own implications. And in as much as that theory doesn't stand now, there are still some implications that it can give us to be able to use it, even in our current teaching. And so the implication of Bacon's idea in today's science teaching is that students are being taught nowadays to learn how to draw conclusions from observations. Yes. In the scientific process, observation is also part. And if you observe well, you should be able to draw conclusions. Remember, we spoke about observations and inferences. In as much as some observations are not correct, we also don't dispute the fact that observations gives us facts. Because if I see metal, if I see that this metal is hard, obviously it is hard. It's the physical appearance that I'm looking at. Okay, before you even go to the inward appearance, before you even go on to what makes up that particular thing. So observation is also important in science. And in as much as we are teaching our students to be practical, we should also teach them to draw conclusions from observations, things that they see. But even in the laboratory, we rely on our senses. We rely on our observations. If you are to prepare ammonia gas, and aside those quantitative and quantitative tests that you can do, you can also do some qualitative tests where you smell the gas, and based on the smell, you can generally conclude that that gas is ammonia. Okay, and so we should teach our students to make reasonable observations and also to draw conclusions from the observations that they make. There are times we can make general statements based on observation. We can make inductive reasoning, inductive statement based on observation. Okay, there are times we can do that. But it's a skill that our students should learn to cultivate. They should learn to draw conclusions from observations. Now, aside the implication, there are also some criticisms that also followed Bacon's philosophy. And because his philosophy was more based on observation, there were concerns as to, one, what about the phenomena that we can't see with our eyes? Because once I can't see, I can't observe it. Okay. We can't see a lot of microbes, a lot of viruses, a lot of bacteria. So we can't see them, but they affect our lives. We can't see gravity. I don't know if you can see gravity, if you can see air, potential energy, kinetic energy. We can't see them, but they're actively in play. Okay, so that was one of the criticisms that came out from that philosophy, Bacon's philosophy, that there are some phenomena that we can't observe, we can't see with our eyes. So once we can't see with the eyes, then it means it doesn't exist. Okay, and the other one says observations cannot be made without prejudice. Observations cannot be made without prejudice, and it's very simple. Some of us are colorblind, so we are not able to see the colors right. So I might see something and that might be red to you, but that might be that might be orange or burgundy to someone. Okay, and remember we've learned that scientists have their own opinions or view about things. They see things differently. They don't see the things as the way we see it. Okay, so I'm making an observation and I see this color to be red. You also come and you see this color to be wine. Whose are we accepting? You see how it is? Whose are we accepting? And so we can't make observations without prejudice. Everyone will have her own view. What you might see as 6, I might see it as 9. And I have to respect your opinion, and you also have to respect my opinion. By 9 instance, whose are we accepting? Okay. And the other one says that scientists may disagree about an event worthwhile to be observed or which data to be collected. Okay. So a group of scientists would disagree that we are observing this particular thing. Which data do we collect? Okay. What do we even observe? Is what we are observing the right thing to observe? Is the data we are collecting the right data to be collected? You see? So all these things also come in play. Okay. And the last one that actually refuted Bacon's theory was the fact that we can't record of any scientific discovery that has been made using Bacon's theory, no, Bacon's idea. Other theories came up, and then a lot of things have been developed. But for Bacon, we can't think of any proper scientific discovery that has been made using his idea or his philosophy. So, in as much as some component of his philosophy is good, it all boils down to the fact that it's not accepted. You can't make general statement because you see a voucher with you see a dog or a vulture and the vulture has bald head, okay, or you see a chicken. A chicken is a bird, and a chicken can't fly. Or it can fly, but not for a long period, a long distance. You see a duck, a turkey, and then they can't fly over a long period of time. So you say that all birds can't fly. There are eagles and falcons flying in the air. Okay, so general statements in some instances are wrong. They are corrupt. But hey, that was what he taught, and that was his line of thinking. We have to accept it. Nonetheless, it formed a very important basis for the development of science, and that was one of the contributors to the knowledge of science. Any questions, please? Any question? Please, are we together? Do we understand what we are saying?
Yeah.
Yes, please.
You said that if one's deduction or one's statement about something, like use the falcon and then the eagle as an example. So if I say that all birds can fly, that may not be correct, right?
Yes.
Even though they can fly, but not as long distance as others.
Yes.
So I can't what the person said is wrong. I have to accommodate the person, and whatever I'm also saying, the person have to also accommodate me. But what about if I come out with proof that what the person is saying is really wrong? You can't say that one. You still have to accommodate whatever the person is saying.
Yes. So you see, you only accommodate it until you can prove it that it is wrong. You get it? Because if you don't, how do I put it? If you don't accommodate the person, and then outrightly you say that it is wrong, what evidence do you also have to buttress the fact that yours is also right?
Not say uprightly saying the person is wrong, but after you have come with a proof that what the person is saying is incorrect.
Exactly. If you have evidence to prove that whatever the person is saying is correct, then you have every right to just discard whatever the person is saying.
Okay.
Yes.
So does it mean observation or conclusion will be thrown out, or it will still be considered?
Oh yeah. Observations form an important part of the scientific steps. You know that. But
Yeah.
to do more and to have more evidence, that's why we go a step further to do experiments.
Okay.
You get it? Observations gives us facts. Observations, remember we talk about observations and inferences. What observation gives us is facts. It gives us empirical evidence that we get from our experiences. But to further validate what observation is given us, that is what we go a step further to talk about, to do experiments. So observation is not wrong, it is correct. But to further do more, that is why we do experiment, to further give credibility to whatever observations that we have. So after carrying out the experiment and we realize that our observation is correct, then we are fine to go.
Thank you, sir.
Thank you too. Is there any other question? But okay, so to the class. Generally, do you think because theory makes sense? Generally, do you think because theory makes sense? And if it does, how? How does it make sense to you? And if it doesn't make sense to you too, why? Yeah, Mr. Solomon. Mr. Solomon.
Yeah, so to me, I think it doesn't make sense. Because he said that we have to observe something before we can. But what if we can't see those things,
Mhm.
and then as such we can't observe those things, it means that that thing can't be considered to be a matter or anything of that sort.
Okay, thank you. Yeah, yeah, Mr. Michael. What do you think about this philosophy?
Okay, so I'll go for it by percentage wise. Percentage wise, I'll say it's true, 70% and a bit false, but I'll stand on true. On the true
Okay.
to the standard. When you're talking about categories of humanity, maybe you are doing classification by observation. And observation doesn't only mean by to see it. You can observe
Yeah.
something using your tactile texture, a feel of it,
Mhm.
because observation, me, I'll generalize as using the five sensory nerves.
Mhm.
So if you give birth to a child, the child has this set of organs, can respond to this by observation. You can classify the child as a male. If the
Mhm.
child have this and that, you can classify as female. So per observation, it's helped the other scientists to develop the mechanism of bringing experiments. So me, I'll strongly agree with it. But without his philosophy, they won't bring out to do more experiments or do more tests about it. So observation won't give you 100% accuracy, but it will give you a gist of the entire matter. So yeah, it's true.
It's true.
Yes.
It's true. I agree. It's true. Yeah. To an extent, it might be true. Because as I said, if you give birth to a child has a penis, a child has whatever, no breast and no. Obviously, the child is a male, right? And that is based on observation. And you can make a general statement that all individuals with a penis are males, and that is accepted. That is an inductive reasoning that is accepted. So to an extent, inductive reasoning is true. To an extent, too, it's not that true. So as scientists, and again, it forms part of the process. We can't actually do or handle things without inductive. They are part of the whole process, and we have to observe that. Okay. Thank you all. Any other question? If not, we move on.
Okay, sir. So what Francis Bacon said, making a
Mhm.
general statement by observation is that term as logical deduction. That's inductive.
Yes, we make a general statement based on here.
Okay. Thank you.
All right. Thank you, sir. Okay. Now, so that was Francis Bacon and whatever he said. After Bacon, there was another philosopher who also came into the limelight with his philosophy. That's Karl Popper. And we're going to look at what he also.
Hello, sir. Hello, sir.
Yes, Madam Linda.
Please, have you stopped sharing your screen, or it's my side that I'm not?
My screen is on, please.
Oh, okay.
You can't see my screen, eh?
Yes, please.
Please, is it the same with all of you?
Yes, it's correct.
Then let me.
Okay. So, Madam Linda, please, can you check your network?
All right. Thank you,
All
sir.
right, thank you. Thank you. All right, so Karl Popper also gave a contradictory view from Bacon's point of view. Now, Karl Popper actually wanted to generate scientific ideas. Okay, that actually saw the achievement of other great philosophers like Newton, Einstein, and then Bohr, and all those stuff. Okay, we are not going to bore you so much into this. And he was regarded as one of the most important and greatest philosophers to ever live. He didn't only work around science. He also looked at a couple of fields, political theories, social theories, and all those things. Okay? And his idea about science was quite a reverse of Bacon's philosophy. Bacon was saying you make general statements based on observation. Now, according to Karl Popper, which is the reverse, instead of you making general statement based observation, you start with the generalization and you make a specific statement, which was the opposite or the reverse. So instead of arriving at generalization, you begin with the generalization and whether it is right or wrong. Okay, so you don't start with your observations or your individual statement. That's so according to what do you call it? Francis Bacon, what do you call it? Sodium chloride is a salt and it's a crystalline. Calcium chloride is a salt and it's crystalline. So all salts are crystals. That is a general statement. All salts are crystals. And you started with a specific statement. Now, according to Karl Popper, don't do that. Make a general statement. So all salts are crystalline. Sodium chloride is a salt, and so sodium chloride is a crystalline. Magnesium chloride is a salt, so magnesium chloride is crystalline. Then you make your specific, what do you call it, statement. And you back it with evidence to prove if your statements are correct. Okay, so and in practical terms, this is what he wanted us to do. So you make a general statement. All metals are solid. Okay, all metals are solid. That's what we are saying. All metals are solid. Now, if all metals are solid, now you come to your individual statement. You pick aluminum. You look at aluminum. Is aluminum solid? Okay, so aluminum is solid. So now aluminum is a metal. Then you put it somewhere. You pick zinc. Look at zinc. Okay, now zinc is solid. So for my general statement that I made, zinc is also a metal. And you do that. Now, you don't just end there. You have to bring evidence to buttress or to validate whatever you are saying. Just the statement itself is not enough. You have to bring evidence to validate whatever you are saying. And until there is a contradictory evidence, whatever statement that you are making is valid. Okay? Whatever statement that you are making is valid. So until you see mercury, and you find out that mercury is a metal, but mercury is not solid, which actually disputes the fact that all metals are solid. Everything stands. You can accept that metals are solid. All metals are solid. But until there is evidence of mercury, which is liquid, everything stands. Okay. And so he also moved on from the observation aspect to actually giving or supporting your claims with evidence. And he was the first person to use the word falsify. To falsify something, to bring out contradictory element or statement to prove that whatever the other person is saying is false. So Karl Popper was the first person to actually develop or come out with what we call the falsification theory, which says that until there's contradictory evidence to prove a particular statement, the statement remains valid. And science actually thrives on this a lot. And remember, one of the characteristics of science, we say science can be easily falsified. Yes, scientific analysis can easily be falsified. and it can only be falsified through evidence. It can also only be falsified through what? Evidence. Okay, and so this is what Karl Popper also taught. That don't make inductive reasoning, rather make deductive reasoning. Inductive reasoning, you are starting from specific statements to draw general conclusions. But for deductive reasoning, you start from generalization to draw specific conclusions. Are we together? Are we together? Thank you. Okay. Now, that is also to say that Francis Karl Popper is against scientists making statements based on observation. He believes that as a scientist, you should be free to make your statement. Okay, but rather the truth of the statement should be tested. Don't just come and make statements and then leave like that. No, you can make statements, but the statement should be tested. And once there are enough evidence to test your statement, it is accepted and as true. That is it. But until your statement is falsified, it is accepted. We only falsify your statement when there is enough evidence to actually contradict whatever you are saying. So he wasn't against the fact that don't make statements. No, make it, but prove to us that your statement that you're making is correct, so we can accept it as scientific knowledge. And the proof should also come from rigorous scientific experiment. Rigorous scientific experiment. That is the only way we can what? We can accept. Okay? That is the only way we can accept it. And so according to Karl Popper, knowledge is held to be true unless there are evidence to prove that it is true, and there is no knowledge to contradict it. Until we've proven that your statement or your knowledge is true, it is not knowledge. It only becomes knowledge when we've proven that beyond reasonable doubt that it is true, and that no other theory can contradict it. When we've accepted, when we've proven beyond reasonable doubt that your knowledge is true, and there's no knowledge to contradict it, that is when we accept that your knowledge is true. And so his philosophy was called a critical rationalization. His philosophy was called a critical rationalization philosophy. That knowledge should be accepted only when it is proven beyond reasonable doubt that it is true, and only when there is no other knowledge to contradict it. That is only when we can accept that a knowledge is knowledge. The philosophy of critical rationalization. Any question, please? Any question, please? Okay. Now, in addition to this, Popper also proposed his own scientific method, which is supposed to be used to generate knowledge. According to Popper, he generated his own scientific knowledge, scientific method, which according to him should be followed if you want to come out with scientific knowledge. Okay. According to him, you recognize the problem, formulate a theory that could solve the problem, you do rigorous testing, you reject or you falsify your theory. Okay, you establish a best fit theory, okay, for the available evidence. And when you look at it, you see a very direct link with the current scientific method. So don't you see that? Don't you see a direct link with the current scientific method? Exactly. Because you recognize a problem. That is identification of problem, right? You formulate a theory. That is formulating a hypothesis. You formulate a hypothesis. You rigorous testing, experimentation, and analysis. We reject faulty theories. So you falsify your theories, and then you do a conclusion based on evidence. So there's a direct link. When you look at this with the current scientific method, there isn't any difference. There isn't any difference. And so that was the scientific method that Karl Popper also proposed, which worked, which is perfect. Okay, so before you come out with this any scientific knowledge, you should have this. You should go through this to provide enough evidence to actually validate whatever you are saying. Now let's look at the implications of his theory or philosophy. So with every philosophy, we look at the implication and we look at the limitations or the criticisms. Now, according to Popper, the implications of his philosophy is that our students should always be presented with tasks or problems, and they practice the skill of formulating hypotheses and go ahead to design a number of experiments. Yes. So, all developing our students' ability or skills. So, our students should be taught how to formulate hypotheses. And based on a hypothesis, they should be able to taught how to develop a number of experiments to test the hypothesis. And get to know that we test hypotheses. Yes, hypotheses are tested to ascertain whether they are true or not. So that is the goal of hypothesis. It's a guess. You guess, and out of the guess, you test whether it is right or wrong. And so, according to Popper, you train our teachers, our learners to be able to develop the ability or skill to test for hypothesis. And not just formulate a hypothesis. They should be able to formulate a hypothesis, come out with hypothesis. They look at situations and then they're able to reason and come out with hypothesis. And not just only come out with a hypothesis, they should be also able to design experiment to test for the hypothesis. You see, so that is coming from Karl Popper. That is what his theory actually implied, and that is what it's demanding of us as teachers to do. Training our students to be able to reason well and come out with hypothesis, proper hypothesis, and out of that they should also be able to develop and design experiment to test for that hypothesis. And that is also to say that theory was also void of criticisms. There were a lot of criticism. Okay, and one of the major criticism of that theory was the fact that one scientific theory cannot be tested alone, and it's true. Before you test some theories, you need to employ other theories to be able to test a particular theory. Okay, before you test a theory, no one theory works alone, works on its own. No, so we normally say that no man is an island. Exactly, no theory is an island. There are some theories, or most of the theories, you will need other theories to also come into play before you can test them. Okay, so one scientific theory cannot be tested alone because each theory is a set within other theories. So if you pick one theory and you say you want to test it, it's quite not impossible. Unless you work with a handful and those 4 theories before you can be able to actually test this theory. And so that was the only criticism from Karl Popper's philosophy. Any questions so far? Any questions so far, class? Any questions so far? Now, if there are no questions so far, then let me ask. So, what do you think about his theory? What are your views about Karl Popper's philosophy? What are your views about his philosophy? What are your views about his philosophy? What do you think? What do you think about his philosophy? Yes, Madam Pamela.
Okay, I would say it's 100% correct because science is based on evidence, not
Okay.
only observations. Yes, please. Thank you.
All right. Okay. All right. Yeah, Mr. Solomon.
And then say to add it to what Madam Pamela said, I also think that Karl Popper's philosophy is unbiased, unlike Francis Baron's own, which was biased.
What do you mean by unbiased? That is quite.
Okay,
What do you mean by
so
unbiased?
when Francis Baron's his philosophy, he said that anything that let's assume a matter, if it's hard, then it's matter because we've observed it. And then so it means that if I take like mercury and then it is soft, but because it is hard, I have to assume that it is metal. And then it goes on that if let's assume something is not hard, a metal that is not hard. So does it mean that that thing is not metal?
Okay.
So based on that observation, it makes that statement bias.
Okay. Okay. All right. Thank you. Is any other view? It's like only two perspectives. What do you think about Karl Popper's theory, philosophy? What do you think about Karl Popper's philosophy? Is someone talking? Hey. Last. The question is to us. So, what do we think about the theory? Yeah, Mr. Richard. Sorry, Richmond.
Yes, mine is question.
Mhm.
I want to ask question.
Okay.
My question is, according to Karl Popper, he stated that to test a theory, there must be an other theory before it can be tested. So does it mean that you getting your theory without having another theory, meaning you can't test that theory to become proved by the whole scientists, or I want to know whether this particular theory function as it is stated, or if I am having my theory and I want to test it, meaning that theory can't be tested.
Okay. So,
Like for instance,
mhm,
for instance, to know communicable disease is how communicable disease is being affected. Meaning, without getting any theory attached to this idea or theory, meaning it can be tested or to know how it is being affected.
So, okay. So, according to what do you call it? Popper. No, so that was actually a criticism. The he didn't believe that you can test for a theory on its own. No, he stated whatever he has to state, but per analysis, it was found out that it's not true because no one theory can be tested alone. Okay, you want to test for titration, you want to do a theory of gases. No, the theory of gases has a lot of other gases, other theories in play. So proper statement is statement, but one of the restrictions, one of the limitations to that theory was the fact that you can't test a theory alone without applying other theories. You get it? And it is true. You can't test a theory now by not applying another theory. Which one are you going to use? Even in the laboratory, there are theories on glasswares, theories on instrumentation. Some of the instruments that you use, there are theories on it that you have to apply. You see, so you can't work around just a single theory and like that. No, you have to apply other theories. You have to allow other theories to come in play before you can accept that. So that was the criticisms about his theory. Not that was what his theory was saying. Okay, I believe that is yes. Is that okay, Mr. Richmond?
Okay, sir.
Okay, Mr. Eric.
Hello, sir.
Yeah, Mr. Eric.
Okay, sir. Based on Karl Popper philosophy, it gives room for critical rationalism. Here, when we look at this scientific methods for everyone to come out with ideas that are rational. Hello?
Mr. Eric, we can't hear you. Hello. Yeah. Can you please move away from the noise a bit?
I said based on Karl Popper's philosophy, it beats.
Yes, we can hear you now.
The network.
Mr. Richmond, can you move to a better place? Sorry, Mr. Eric.
Hello, sir. Yeah, I was saying that based on Karl Popper's philosophy, it gives room for critical rationalism. In the sense that when you look at this scientific methods, the first aspect talks about identifying a problem. And with this, it helps one to be able to come out with important facts that may be detailed based on what the problem that you may be identified.
Okay. Yeah, so that is it. So that is it, class. That is it. And whatever theory that is or philosophy that is being propounded, regardless of the fact that some aspects of that theory might be wrong, doesn't dispute the fact also that there are some important things that we can get from that theory. Okay, it doesn't dispute the fact that there are some important things that we can get from that theory. And so we in as much as that is it, we should be able to also look at the positive side of those theories. Is any other question? If not, we continue. All right. Now we move on to talk about another philosopher, Thomas Kuhn. Thomas Kuhn. We are also going to look at what Thomas Kuhn proposed and what he says. And, yeah. Hopefully, we'll be able to. Yeah, that's good. Now, Thomas Kuhn actually summarized all that he wanted to say in his book named The Structure of Scientific Revolution. So everything that he wanted to say, every idea that he had, everything that he wanted to say, he put everything together in his book known as The Scientific Revolution. So you want a chance on this, you can just read it. Now, according to Thomas Kuhn, he saw science as a well, people thought that science was just a progress. Okay, science actually progressed by adding new theories. Okay, so as we are going, we add theories, we accept this theory, and we progress. And we dismiss or we discard the old theory. Okay, so that was what he taught. And that was what people thought, that science actually progresses by accepting new theories and then dismissing the old theories. Now, Kuhn had a different idea. Okay, according to Kuhn, the old ideas, the old theories that were no longer working or that were falsified, rather than throwing them away, we should modify them. Okay, we should modify them so that they offer new explanations. Instead of just throwing them away, we should just modify them. And at that period of time, that was how science was. Once a theory is falsified, or once a theory is discarded or disregarded, it is being thrown away. It is no more in use. And so he thought that shouldn't be the case. Rather than throwing these old theories away, we should just accept it. We should just pick them up, modify them, so that they can make new explanations. They can be used to give new explanations to new things. So we shouldn't just throw those theories away. No. Okay, shouldn't just throw those theories away. We should rather pick them up, modify them. Areas that need to be modified, we do the areas that need to be change, we change them so that we can beef it up to explain new things. And he introduced the term paradigm. He also introduced the term what? Paradigm. In the sense that, or looking at series of theories that come together to form the framework for other things to be to come out of. Okay, so he used the term paradigm, but that was his basic ideology. Don't throw the old theories away. These old theories played a part. Okay, in as much as they have been refuted, they played a part. They contributed a bit. Okay, it's like a series of successive journey. Okay, where each theory contributes bits. They contribute bits. They can contribute bits until we get the whole. Okay, so the fact that they were discarded doesn't mean that they are not important. No, they contributed something towards the big giant science that we all have. So we can't just throw them away like that. No. known. Okay, and so paradigm is described as the web of interconnected theories and ideas, providing a framework supporting scientific experiments. Yes. And according to Kuhn, science operates in two clear paths or phases. According to Kuhn, science operated in two clear phases. We had the normal science phase and the revolutionary science phase. According to Kuhn, these are the phases that science actually works. The normal science phase and then the revolutionary science phase. Now let's look at let's look at what this phases involve. Now, in the normal science phase, according to Kuhn, scientists work on puzzle-solving activities, gradually building up solutions to problems. So, in a science phase, this is what scientists do. So, in the normal science phase, this is what the scientists do. They work on puzzles, solving activities, gradually building up solutions to problems. Okay, he sees science to be full of puzzles. Okay, he sees science to be full of puzzles. Excuse me. And scientists as puzzle solvers. And so once we are scientists, you are engaged in puzzles. And you saw the community or the environment to be full of puzzles. And the puzzles means problems. Okay, so he saw scientists to be problem solvers. Problem solvers. And so in the normal science phase, we are just solving problems. We are just solving problems. Okay, and in the normal science phase 2, there can be the rise of anomalies. Issues can rise up. Things can happen. That is the phase. That is what happens in that phase. So that is basically what actually happens in the normal science phase. Now, in the revolutionary science phase, that is when things begin to happen. That is when events actually causes change to occur. Okay, so what happens is that in the normal science phase, scientists are solving problems. They see a problem, they see puzzles, and they solve it. In the course of solving the problem, in the course of solving the puzzles, there can be anomalies. Problems can arise. Criticisms can arise. Okay, criticisms can arise. Anomalies can arise. So when in that phase, these criticisms arise, that actually refutes whatever paradigm that is, or whatever problem that is being solved. That is when the revolutionary science phase actually comes in, where you have events resulting in change. And so in the revolutionary science phase, it is characterized by changes and the introduction of a new paradigm. Because in the normal science phase, problems have occurred. And in the course of solving that problem, we've also encountered other anomalies. So it is that anomalies that actually usher us into the revolutionary science phase. And in that science phase, it is characterized by just scientific and significant changes. And so these are the two phases of science that Kuhn actually proposed. That was his own point of view, or that was his philosophy. Whether to accept it or not, that is his own philosophy. And as I said, we need to accept these philosophies because they form part of the bigger whole that we see now. Now let's look at the implication of Kuhn's philosophy in our current world when it comes to teaching science. Now, the implication of Kuhn's view in science education is that students should be able to modify any hypothesis they formulate that do not fit the data. So remember, one of the philosophers advocated for the fact that we should teach our students how to formulate hypotheses, and not just formulate hypotheses, but should also be able to develop experiments to test those hypotheses. Now, Kuhn is also saying that in addition to that, we should be able to also train our students to be able to change the hypothesis in case the hypothesis or the data that they develop or they collect doesn't meet or fit the hypothesis. And so each hypothesis is to guide us. It's just a guess. For example, people somewhere are suffering. And so you go there as a scientist to find out solutions to the problem. And then from there, you say that, oh, okay, so these people, you guess, oh, that, oh, okay, from the symptoms and the way that these people are suffering, probably it's cholera. It's a guess. You're making a guess because you don't, as at that time, you don't have evidence to actually buttress whatever you are saying. So what that you make is just a guess. Okay. And that is the hypothesis. You make an inductive and an educational guess. Now, you move on to collect data. Once you realize that the data you have doesn't support the hypothesis that you stated earlier, you should be able to change it. You should be able to change it. And that is what Kuhn is advocating for. That we should be able to teach our students to be able to change their hypothesis. Once they realize that the data that they have doesn't support the hypothesis. Okay. Once they get to understand that the data that they've collected to test the hypothesis doesn't support what? Once they realize that the data they've collected doesn't support the hypothesis that they formulated, they should be able to change it. They should be able to change it. And it's a skill that we need to teach our students to be able to develop. Not just being able to formulate the hypothesis and then formulate experiments to test the hypothesis. But in the instance whereby they encounter changes, where they encounter situations where the data they collected doesn't fit the hypothesis, they should be able to go back and change the hypothesis. We should be able to teach our students that skill. And he also says that every problem that confronts man is surmountable if the right paradigm shift comes about. Yes, every problem can be solved once we apply the right paradigm shift. And so these are the two implications of Kuhn's philosophy. As I said earlier, every theory, every philosophy, there are limitations. So let's look at the limitations, the criticisms, and the limitations of Kuhn's theory. One is that there's no consistent definition about what a paradigm shift really looks like. We don't know what a paradigm shift really looks like. No, we don't know. We don't know what a paradigm shift really looks like. And so it's sometimes difficult to actually identify what a paradigm shift is. And two is the fact that paradigm shifts can occur without revolution. Changes can occur. Changes can actually occur. And it occurs every time. Now, some theories also describe the same phenomenon, but with different meaning. Yes. You can have certain theories that describe a particular phenomenon, two or more that describe the same phenomenon, but they are coming up with different meanings. And so this is actually the criticisms that arose from Thomas Kuhn's philosophy. Any question, please? Any question, please? Okay, that's good. Now we're just left with two philosophers to talk about, and then we are done with unit 4. And I think just a second, please. Okay. So I just sent the first and the I just sent the such unit 1 and unit 2 onto the WhatsApp platform. I think I told you guys I'll share it with you. So I just shared it. Those online, hope you can see it. Okay. Please don't share the slides with anyone. I'm beginning. And as I said earlier, I don't like sharing my slides. Don't rely solely on a slide. Everything that is in the slide is in the course model. So just go by that. So we have just a few minutes. 2 philosophers that we need to talk about. Matt, I would want to end here and then do that on Monday when we meet for extra 1 hour for the 2 hours. Now, I want my list on latest by tomorrow, so that on Monday when we meet, I can present the list to you and your various topics. So, going on Monday when we meet, we are going to use just 30 minutes to talk about, finish the other 2 philosophers. And then we're going to use 30 minutes to talk about your projects or your presentations. So please present the list to me. After tomorrow, I'm not going to accept any list. After tomorrow, I'm not going to accept any list. And please make sure that you present the right list. I don't want a situation whereby I'll finish with the groups and then later you come back testing me that, oh, this person's name is not on it. No. Once I'm done with the list, there's no addition. I'll submit the list, presentation list to the department for the department to work with that. And so if you come later, I wouldn't be able to add your name. Please let's be a bit smart with these things. No. Give your details to your course rep. Your course rep will send it to me and I'll create the presentation list. Don't stand there or don't be there and then you later bring it. Mr. Abdul, any issue?
My concern is about the list. Like the statement you make that it should be sent in as a Word document.
Yes.
So that IT term, I'm finding it difficult to understand it.
MS Word.
Yeah. Okay.
You just type it in MS Word and you send it to me.
Okay.
Yes, thank you. Mr. Eric. Yes,
hello,
please.
sir. Please, I've sent a document to you on WhatsApp.
Which group is that?
Nah. Oh, come now. And
Not in the group. I sent it there.
Oyoko.
So,
It's Oyoko, right?
Oyoko matter is Kufuya. It's still reading.
Okay. So now I have just two.
Yes,
I have
please.
just 2. Okay, thank you. All right. Yes. So please, the rest. I'm still waiting for you. The rest, I'm still waiting for you. Give me the list by tomorrow.
no,
After tomorrow, please. I'm not accepting any list again. You with your course rep and your course rep will
No, mara to mani.
you with your course rep and your course rep.
Zapal ka dong. Alam ba? Bana.
Oh, sir. Sorry.
Yes.
Yeah, please. So the one you have presented it on the WhatsApp session.
I
That one
can't see
should.
anything. I can't see anything on that. I can't see anything. There's nothing. In fact, I can't even differentiate between because everyone is adding it, and I can't go back. And the instruction was very. Please, Mr. Favor, please mute yourself.
Sir, please, my name is not on the platform. The WhatsApp.
Please, the idea is get your name to your course rep. You don't have course reps, right?
Yes.
So get your name to your course rep. And the course rep will put the list together and send it to me. That was what we spoke about on last week.
Hello, sir.
Yes.
Sir, I'm at UCC. My study center is UCC, but I don't know my course rep.
Please ask. Or if you know all of your colleagues, just come together and send me the list.
Okay.
So please, I'm expecting the list latest by tomorrow. Anyone that submits after tomorrow, I'm not accepting it because I need to work on it and submit it to you on Monday. So please, we are doing that. And so we are meeting on Monday at our usual time, 7 p.m. We'll use 30 minutes to wrap up with Unit 4. And then another 30 minutes to just talk about the presentation and whatever you are supposed to do. I'll share your groupings with you on Monday. And then we'll take it from there. So please, we are meeting on Monday, 7 p.m. as usual, to 8 p.m., just an hour, as agreed upon. Thank you very much. Please, any other question?
Yes, sir.
Okay.
Hello. Hello,
Yes,
sir.
please. Yes, please.
I want to plead on everybody. Anybody that have the nature of science model, the software, the soft copy, should kindly share it on the platform because majority of us we are not getting the hard copy.
You still don't have the hard copy?
No, please. So actually, it's a challenge. So anybody that have the soft copy and can help.
Well, it's very
Okay.
surprising. It's very surprising that you still don't have the.
Yes, sir. Went to our center here twice. I think the first Saturday that we started lectures, we couldn't get the second Saturday, so I got frustrated and then we stopped going there.
All right, so I've sent the soft copy
Okay.
of the model.
Okay. Thank you, sir.
I've sent the soft copy of the model to the WhatsApp platform. So those who don't have can still check it out.
Thank
It's
you, sir.
available at the platform now. All right, thank you too. Okay, I hope that is it. That is it. Any other issue? All right. So yes, Mr. Eric.
Hello, sir.
Yes, Mr. Eric.
Sir, please, please, we are begging
Mr.
if you have.
Mm-hmm.
Any
have what? Come again. I can't hear you.
sample of class question, please kindly send it to the WhatsApp group.
No. The last time I told you that I don't have past questions. I don't have past questions.
Oh, okay. Okay.
No, sorry, but I don't have.
Okay, thank you.
Sorry, I don't have. Sorry. I don't have.
One second.
Sorry, I don't have.
Hello, sir. Hello, sir.
Yes, please.
Yeah, please. I want to do the comparing of the name for UCC pupils, but I don't know how to do it. So, if you
And
can
so,
help me to.
ask your colleagues. I'm sure they are all on the platform, right? So just ask your colleagues who registered for that course. Just DM you.
Okay. And how I will send to you? That is what I'm asking.
My number is my number is there. It's on a timetable.
Okay.
My
So
number
you should
and then
send it on the.
yeah, my
Okay.
number is there. So just send it to me on timetable on my WhatsApp.
Okay,
And
sir.
I'll get it. Yeah.
Okay, sir.
Yeah. Thank you.